XRF Scientific, Australia's world force in sample fusion, proudly presents Modutemp's robotic fusion system. The well-respected Modutemp brand is just part of XRF Scientific's technology division. The fully automated system we see here uses two of the proven 6-place fusion furnaces and adds automation by motorised carousel units and the EPSON miniature robot. A system like this may be supplied as a complete turnkey project or achieved as a series of incremental additions to one or two standard Modutemp bead makers. An important part of robotic operations is the confirmation of each step in the process. Here we see the carousel turning through its check station to ensure that each crucible and mould is either in place or has been taken by the robot. Any deviation from the correct sequence would halt the process and raise an alarm to alert an attendant to the problem. It's time to load crucibles into the furnace. That chamber is being maintained at 1100 degrees C. The furnace lid is kept closed as much as possible to minimise any temperature loss, while the robot accurately places each crucible into its respective spindle. The spindles rotate continuously during the fusion process to ensure complete homogeneity of the fused sample. All samples will normally be in the furnace for typically 8 to 9 minutes to achieve complete fusion. Every sample to be fused has been dried, ground, weighed and mixed with a weighed quantity of flux before being added to the crucible. Each crucible and mould will be returned to its original position during the process in order to preserve its identity. Once completely charged, the basket can be loaded into its carousel, ready to be fused as soon as the furnace is available. While the robot is loading furnace 2, we can see the carousel turning through its check station, confirming that each crucible and its respective mould has been taken before proceeding to the next. Once all the moulds have been loaded, the mould carriage drives them into the chamber to be heated, ready for pouring the beads. With the precision available with robotic pouring, the crucible is tipped, then lowered to just touch the surface of the poured bead. The remaining molten flux is promptly drawn from the crucible, ensuring a complete fill of the mould. The tips of the specially designed robot gripper are made from titanium to avoid contaminating the crucibles and can safely grip the crucibles from either side as well as the moulds. With pouring completed, the filled moulds are slowly drawn out to their cooling position, where electric fans blow air on them from below. While the beads are still cooling, the robot is collecting ready cooled beads from the other furnace. It places them back into their original positions in the basket so that their identity is maintained. The entire basket can then be unloaded and the cooled beads then removed from their moulds. This basket is then ready to be charged with fresh crucibles and reloaded into the carousel. The system filmed here is now in constant use, processing 50 bauxite samples every hour. The indicator lights show the system's status at a glance, while the control panel maintains a clear readout of temperatures and where each furnace is in its program. XRF Technology produces the fusion equipment. XRF Labware produces the crucibles and moulds necessary for the process, and the fusion fluxes are produced by XRF Chemicals.